The universe is expanding continuously, stretching farther and farther into the depths of the unknown, a phenomenon that challenges the limits of human imagination. From the earliest civilizations, humans have looked up at the night sky in wonder, marveling at the countless stars, planets, and cosmic events that seem both eternal and distant. In 1929, a breakthrough came when scientists discovered that the very elements constituting our bodies, carbon, oxygen, nitrogen, and more, originated in the cores of stars. This realization connected us intimately to the cosmos, showing that we are not separate observers but products of the same forces that shape the universe itself. By 1957, scientists had deepened their understanding, recognizing that the sky is not just a canvas of beauty but a dynamic, powerful system whose influence reaches far beyond what the naked eye can perceive. Despite all this knowledge, much of the universe remains an enigma. From the tiniest quantum fluctuations to the largest galactic clusters, there are countless phenomena that we barely comprehend, leaving humanity to wonder about the very nature of existence. Why do we exist? Why do planets form? What other possibilities might the cosmos hold? We often fail to notice problems until they become critical, even when the warning signs are visible. In the cosmic realm, one such warning is coming from Betelgeuse, one of the largest stars visible in the night sky. Betelgeuse has recently displayed unusual instability, trembling in ways that suggest significant changes within its interior. Its very size and power have made it a focus of study for centuries. To put it in perspective, Betelgeuse is so immense that it dwarfs our Sun, making it appear almost like a tiny ember in comparison. This star is not ordinary, it is a red supergiant, one of the largest stars ever observed, located more than 640 light-years away from Earth. In human terms, that distance seems almost incomprehensible. Even if we could travel at the speed of light, it would take over 6 centuries to reach it. With our current technology, a journey of this magnitude would take more than 12 million years, far exceeding the entirety of human history. The immensity of Betelgeuse reminds us of the staggering scales and forces at play in the universe. Despite appearing calm from our vantage point, stars like Betelgeuse are anything but quiet. This particular red supergiant has long been known as a pulsating variable star, meaning its brightness changes over time due to internal and external processes. Its luminosity fluctuates dramatically, ranging from magnitude 5 to magnitude 0. A difference far more pronounced than that seen in most stars. These pulsations occur in cycles, some lasting just a few hundred days, while others stretch over several years. In February 2021, Betelgeuse reached one of its lowest recorded brightness levels, a V-band value of 1.614, drawing worldwide attention and sparking widespread speculation about its future. The red color of Betelgeuse is equally striking. Its surface temperature is approximately 3,500 Kelvin, cooler than the Sun's 5,500 Kelvin, which means it emits less energy per unit area despite its massive size. These cooler temperatures, combined with its immense volume, make it appear as a dim, red giant in the sky, yet the forces within it are far from subdued. While Betelgeuse had remained relatively stable for centuries, recent observations indicate that it is entering a more volatile phase. This change is driven by processes occurring deep within its core. Betelgeuse, like all red supergiants, burns hydrogen in its core through nuclear fusion, converting it into helium. As the hydrogen supply diminishes, the outer layers of the star begin to expand, while helium accumulates in a shell surrounding the core. When helium starts to fuse into heavier elements such as carbon and oxygen, bursts of energy are released irregularly, destabilizing the star's structure. This causes the outer layers to expand and contract, producing the pulsations that are observed as variations in brightness from Earth. These pulsations are not merely superficial. They represent the inner workings of a star struggling to maintain equilibrium between gravitational collapse and outward radiation pressure. The energy released during these pulsations generates powerful stellar winds, blowing vast amounts of material into space. This mass loss significantly affects the star's evolution, redistributing matter and altering internal dynamics. The expansion and contraction of Betelgeuse's outer layers create a rhythmic, almost heartbeat-like pulse, allowing astronomers to listen to the star and gain insight into its internal processes. To study Betelgeuse in detail, astronomers rely on two key observational techniques: photometry and spectroscopy. Photometry measures changes in brightness over time, revealing patterns in the star's pulsations. Spectroscopy examines the light emitted at different wavelengths, providing information about temperature, chemical composition, and motion. When combined, these methods offer a comprehensive view of the star's behavior. Advanced computer simulations also play a crucial role, modeling the complex nuclear reactions and fluid dynamics occurring within the star. By comparing simulations with real observations, scientists can understand how Betelgeuse's pulsations respond to internal changes, effectively connecting theory with reality. A central process driving these pulsations is stellar convection. Energy produced in the core rises toward the surface in convective currents, with hot material moving upward and cooler material sinking. This circulation transports energy to the outer layers, altering surface brightness. When the energy reaches the surface, the star appears brighter, and as it wanes, the star dims. These convection currents create predictable pulsation cycles, revealing the delicate balance between gravitational forces pulling inward and radiation pressure pushing outward. As Betelgeuse approaches the final stages of its life, these pulsations become more pronounced. The star's core is gradually running out of nuclear fuel, and in the distant future, this red supergiant will end its life in a spectacular supernova explosion, releasing a tremendous amount of energy and scattering elements into space, a process vital for the formation of new stars and planets. Until then, Betelgeuse continues its rhythmic expansion and contraction, offering astronomers invaluable insights into the life cycles of massive stars. Studying Betelgeuse and stars like it helps humanity understand not only the mechanics of stellar evolution but also the origins of elements that make life possible. Every fluctuation in brightness, every surge of energy within the star, provides a window into the complex, often violent processes that govern the universe. From the first spark of nuclear fusion in its core to the eventual cataclysmic supernova, Betelgeuse stands as a testament to the grandeur, power, and mystery of the cosmos. So next time you gaze at the night sky, remember that these distant stars are not merely points of light, they are dynamic, ever-changing systems whose histories span millions of years. They tell stories of creation, destruction, and the incredible forces shaping everything around us. Stars like Betelgeuse are more than astronomical objects. They are cosmic laboratories, offering humanity a chance to explore and understand the universe on a scale far beyond Earth. Let me know what you think in the comment box. If you enjoyed this journey through the cosmos, don't forget to like, share, and subscribe to Discovery at 2.0 for more fascinating explorations into the universe. The stars are alive, and their story is ours to uncover.